Hurricanes are big. They are incredibly powerful. They always have been. For as long as people have lived near coasts, hurricanes have brought fear and destruction. They sweep in from the ocean, they tear down homes, they flood towns, they take lives. It's a force of nature that feels unstoppable. Imagine living in a place where hurricanes hit often. You build your house, you raise your family. Then, one day, the sky changes. The wind picks up. The ocean starts to churn, you hear the warnings, you board up your windows, you evacuate if you can. But sometimes, there's nowhere safe enough. The storm comes, and when it leaves, a lot of what you knew is just gone. Ruined, washed away. People have always looked at these storms and felt small, helpless. It's a natural human reaction to want to fight back, to want to do something, anything, to stop it. Or at least to make it less bad. For a long time, the only thing we could do was brace for impact. We could try to build stronger houses, we could try to get out of the way, but the storm itself, that was just something you endured. But as science grew, as our understanding of weather got better, some people started to think, what if we didn't just have to sit there and take it? What if we could actually change a hurricane? What if we could make it weaker? Or even make it go away? It sounds like something out of a science fiction movie. But the idea, a real desire to control nature, started to grow. It came from a place of genuine concern, of wanting to protect people, of wanting to prevent so much suffering and damage. In the mid-20th century, after World War II, there was a big boom in science and technology. People had seen what incredible things could be done with new inventions. They had seen how powerful technology could be. So it wasn't too far-fetched, at least to some, to think about taking on a hurricane. If we could fly to the moon, if we could split the atom, surely we could mess with the storm, right? The stakes were so high. The damage from hurricanes was so immense. The economic cost was huge. And the human cost, the lives lost, was even worse. So the idea wasn't just idle dreaming. It became a serious goal for some very smart people. They started looking at the problem of hurricanes in a new way. Not just as a thing to predict, but as a thing to potentially change. They wanted to find a way to intervene, to somehow poke it or prod it or trick it into losing its strength. This wasn't about being arrogant. It was about solving a massive problem. It was about protecting coastal communities. It was about saving lives and billions of dollars in damage every year. They knew hurricanes were complicated. They knew they were fueled by warm ocean water. They knew they spun with incredible energy. But they also knew that these storms had specific structures. They had eyes, they had eye walls, they had rain bands, maybe, just maybe. If you understood those parts well enough, you could find a weak spot. A place where a small push could cause a big effect. A domino effect that would lead to the storm falling apart, or at least becoming much gentler. This kind of thinking led to some pretty wild ideas. Some were more realistic than others. But the underlying drive was the same: to stop the monster, to make it less scary, to give people some power back against something that felt totally out of control. It was a big goal, a heroic one even, but it also carried huge risks. What if you tried to mess with a hurricane and made it worse? What if you tried to change its path and sent it towards a different city instead? These were questions that would come up later. But first, people had to figure out if they could do anything at all. The very first step was to ask, is it even possible? Can we truly stand up to a hurricane and win? That question and the desire to answer it is what really got things going. And one of the most extreme but persistent ideas that floated around was about using nuclear bombs. It sounds crazy, and it is. No, the National Weather Service did not try to nuke a hurricane. Let's be very clear about that right away. It's a persistent myth, one that pops up every now and then, especially when a big hurricane is heading towards land. But it's not true. No government agency, certainly not the NWS, ever seriously considered using nuclear weapons to break up a hurricane. The idea itself, though, is interesting. It comes from a basic, but wrong, understanding of both hurricanes and nuclear bombs. People hear nuclear bomb and think of immense, unstoppable power. They think, if it can flatten a city, it can surely break up a storm. But the two things operate on completely different scales and with different kinds of energy. Think about what a hurricane is. It's not a solid object you can blow up. It's a vast system of wind, water, and heat. It's a giant heat engine powered by the warm water of the ocean. It draws up huge amounts of moisture. It releases massive amounts of latent heat when that moisture condenses into rain. The energy released by a large hurricane every single day is mind-boggling. We're talking about the equivalent of many, many atomic bombs. Some estimates say a hurricane releases energy equal to a 10 megaton nuclear bomb exploding every 20 minutes. So, a single nuclear bomb, or even a few, is just a drop in the ocean compared to the storm's overall energy budget. Imagine trying to put out a massive forest fire by throwing a single bucket of water on it. It just wouldn't do anything. The fire is too big. The hurricane is even bigger. It might create a temporary hole in a small part of the storm, but the surrounding winds and moisture would quickly fill that hole. The storm's engine, the warm ocean water, would still be there, still feeding it. It would just reform around the disturbed area. And then there's the problem of how a nuclear bomb works. It creates a massive, instantaneous explosion, heats up a small area to incredible temperatures. It generates a huge shockwave. But hurricanes are about atmospheric processes, not solid objects. The bomb's energy would dissipate quickly in the vastness of the atmosphere. It wouldn't disrupt the large-scale wind patterns that define the hurricane. It wouldn't cool the ocean. It wouldn't change the fundamental physics that create and sustain the storm. But beyond the scientific impossibility, there's the incredibly dangerous fallout issue. A nuclear bomb, by its very nature, creates radioactive fallout. If you detonated a nuclear bomb in the atmosphere, especially inside a storm system, where would that fallout go? The hurricane itself would pick up all that radioactive material. It would then rain it down over a massive area, potentially affecting huge populations. It would contaminate vast stretches of land and water. The cure would be far, far worse than the disease. You'd be turning a natural disaster into a human-made nuclear disaster, affecting potentially millions of people for generations. And what about the political and ethical side? Imagine a country detonating a nuclear weapon inside an international storm system. It would be an act of war. It would be a catastrophic violation of international treaties. It would cause global panic and outrage. The idea is so utterly reckless and dangerous that it's just not something anyone in a position of power would ever seriously consider. The source of this myth might be partly from the general public's awe of nuclear power, and partly from the broad public discussion around weather modification back in the mid-20th century. People were talking about controlling weather. They were talking about powerful new technologies. It's easy for these ideas to get mixed up and for extreme possibilities to become urban legends. But government scientists and weather experts knew then, as they know now, that it's a non-starter. It's a terrible, impossible idea. So while the idea of nuking a hurricane might sound like a simple brute force solution to an immense problem, it's actually completely unworkable and incredibly dangerous. It's just not how hurricanes work, and it's definitely not how nuclear weapons should ever be used. Scientists, including those at the National Weather Service and NOAA, have always been very clear on this. The conversation around hurricane modification moved in a very different and much more scientifically sound direction. It focused on understanding the storm's natural processes, not on blowing it up. And that direction was called Project Stormfury. While nuking a hurricane was a wild and impossible idea, there was a different, more scientifically grounded approach to hurricane modification. This was Project Stormfury. It wasn't about bombs. It was about something much more subtle: cloud seeding. This project started in the 1960s. It was a joint effort. The U.S. Navy, the National Weather Service, and later NOAA all worked on it. The goal was simple but ambitious: weaken hurricanes by messing with their internal structure. The basic idea behind Project Stormfury came from something called cloud seeding. This had been experimented with for a while. Scientists believe that if you introduce tiny particles into certain types of clouds, those particles, often silver iodide, could act as nuclei. The water vapor would condense around them. This could make the clouds grow bigger. It could make them rain more. So, the theory was if it works for regular clouds, maybe it could work for hurricane clouds. Hurricanes are complex. They have a central eye. This eye is surrounded by a towering ring of thunderstorms called the eye wall. This eye wall is where the strongest winds are. Outside the eye wall, there are other spiraling rain bands. These are like smaller, less intense thunderstorms. The scientists behind Stormfury thought they could exploit this structure. Here's how they thought it would work. You fly airplanes into the hurricane. You drop silver iodide into the rain bands outside the eye wall. The silver iodide would make these outer rainband clouds grow taller and wider. As these seeded clouds grew, they would start to compete with the main eye wall for the hurricane's energy. Think of it like this. A hurricane is a big engine. It draws in warm, moist air. This air rises, cools, and releases heat. This heat fuels the storm. The eye wall is the main exhaust pipe for this engine, where most of the energy is released. If you make the outer rain bands bigger, they start to create their own exhaust pipes. This would draw energy away from the main eye wall. If the main eye wall lost some of its energy, it would weaken. The theory was that a weakened eye wall would expand. When an eye wall expands, the strong winds in it spread out over a larger area. This makes the winds less intense at any single point, so the overall effect would be to reduce the maximum wind speeds of the hurricane. As a hurricane with wider, weaker winds is less dangerous than one with a tight, incredibly strong eye wall. They hope to reduce wind speeds by 10% or even 20%. That would be a huge deal for coastal communities. Even a small drop in wind speed can mean a lot less damage. The project was based on a specific model of how hurricanes worked. This model suggested that supercooled water droplets existed in the upper parts of the hurricane's clouds. These are water droplets that are below freezing but haven't frozen yet. Silver iodide acts like tiny ice crystals. If you introduce them into these supercooled clouds, they would cause the droplets to freeze. This would release latent heat. This released heat would cause the seeded clouds to rise higher. They would become bigger. This, in turn, would start the process of drawing energy away from the eye wall. It sounded like a plausible theory. It was based on the best understanding of hurricane physics at the time. It was a way to intervene that didn't involve destructive force. It involved a subtle manipulation of the storm's natural processes, and it had the backing of some serious scientific minds and government agencies. It was a big deal. They built special aircraft to fly into these dangerous storms. They developed precise ways to deploy the silver iodide. They put a lot of time, money, and scientific effort into making it happen. The hope was that they could develop a reliable method to make hurricanes less deadly. It was a bold step in trying to bend nature to human will, but with good intentions and a lot of scientific rigor behind it, far removed from the sensational idea of nuclear weapons. The first attempts at seeding hurricanes actually happened before Project Stormfury was officially formed. In 1947, a company tried seeding a hurricane off the coast of Florida. They used dry ice. The storm seemed to change direction, but it wasn't clear if the seeding caused it. The plane didn't have any instruments to really measure what happened inside the storm. And a part of the storm hit Savannah, Georgia. Some people thought the seeding caused it. This early experiment showed how complicated and sensitive the issue of hurricane modification would be. Project Stormfury officially started in 1962. Scientists were very careful. They didn't want a repeat of the 1947 incident. They had strict rules about which hurricanes they could experiment on. The hurricane had to be far from land. It had to be unlikely to hit land for at least 24 hours after the seeding. This was to avoid any accusations that they were steering a storm towards someone. One of the most famous experiments happened with Hurricane Debbie in 1969. Debbie was a big, strong hurricane. On August 18th, planes flew into Debbie. They seeded the storm 5 times. They dropped hundreds of pounds of silver iodide. Or what happened? The maximum wind speed in Debbie dropped by about 31%. This was a huge reduction. Scientists were excited, but then, 18 hours later, the storm strengthened again. On August 20th, they seeded Debbie again, and again, the wind speeds dropped, this time by about 18%. This seemed like strong evidence. 2 times, seeding led to weakening. It looked like the theory was working. Other hurricanes were targeted too, like Hurricane Beulah in 1963, but the results were less clear. Some storms didn't react as expected. Some didn't have the right structure for seeding. And a big problem kept coming up: natural variability. Hurricanes are constantly changing. They naturally get stronger, they naturally get weaker, they naturally expand and contract. How could the scientists be sure that the changes they saw after seeding were actually caused by the silver iodide and not just the hurricane doing what it would have done anyway? This was the hardest question to answer. There was no way to have a control hurricane. You couldn't have 2 identical hurricanes, seed one and leave the other alone to compare them directly. Each storm is unique. The scientists did try to account for natural variability. They used computer models, they studied past hurricanes, they tried to build up a statistical case. But it was very difficult to get truly conclusive proof. The observed changes, even in Debbie, could still be within the range of what a hurricane might do on its own. Another big challenge was finding suitable hurricanes. Remember those strict rules. The storm had to be far from land. It had to be unlikely to hit land. This meant that many hurricanes that formed each year couldn't be used for experiments. They either formed too close to land, or their path was too uncertain. This limited the number of opportunities to test the theory. They needed many more experiments to build a really strong case, but they just didn't get enough chances. The project faced other problems. There were technical limitations. Flying into a hurricane, even with advanced aircraft, was dangerous. Dropping the silver iodide accurately was hard. and measuring the precise effects deep inside the storm was also a challenge with the technology of the time. Instruments could only tell them so much, and the ethical questions never really went away. Even with the strict rules, there was always the concern. What if they weakened a hurricane, and it then turned and hit a different area with a weaker, but still damaging, force? Would they be blamed? What if, despite their best intentions, they somehow made a storm worse? Even if the science was sound, the public perception and potential legal challenges were huge. These ethical and public relations issues were always a shadow over the project. So, while Project Stormfury had some promising moments, especially with Hurricane Debby, it never quite delivered the undeniable proof that it worked. It was a complex problem with many variables, and the tools and opportunities available at the time just weren't enough to get definitive answers. It showed that trying to control something as massive as a hurricane was incredibly difficult, even with a seemingly clever scientific approach. Project Stormfury finally ended in 1983. It wasn't because someone decided it was a bad idea or that the scientists were wrong. It ended because the scientific evidence just wasn't strong enough. They couldn't prove it worked. Remember that crucial question: how do you know if the changes you see are from your seeding or from the hurricane's natural behavior? That question never got a clear answer. The changes observed in storms like Debby, while exciting, could still be explained by the natural ups and downs of a hurricane. They just didn't have enough clear-cut examples where the storm only changed after seeding and in ways that clearly went against its natural progression. One of the biggest problems was a better understanding of hurricanes themselves. As scientists studied hurricanes more and more, they realized some things. For example, the theory of supercooled water droplets in the upper parts of the storm, which was central to Stormfury's seeding idea, turned out to be less common than thought. They found that in many mature hurricanes, there weren't as many supercooled droplets for the silver iodide to work on. The storm's clouds were already mostly ice at those higher altitudes. If the silver iodide couldn't find enough water to freeze, it wouldn't release the latent heat needed to make the clouds grow bigger. So, the basic premise of the seeding mechanism was weaker than first assumed. Also, as computer models got better, they showed how complex hurricane dynamics really are. They showed that the storm structure is constantly adjusting. Trying to make a small change in one part of the storm to get a big, predictable change in the whole storm was much harder than anticipated. The storm's internal forces were just too powerful and too adaptable. The ethical and legal concerns also played a big part in its demise. Even if they could prove it worked, what then? If you weaken a hurricane but it still makes landfall, are you responsible for the damage? What if you try to steer it away from one coast and it ends up hitting another? The legal and political implications of purposefully altering such a powerful natural phenomenon were enormous. No one wanted to be blamed for making a situation worse, even unintentionally. It was a liability too great to bear without absolute certainty of positive outcomes. And that certainty was just not there. Another practical issue was, as mentioned before, the lack of suitable hurricanes for testing. The strict rules meant that there were very few storms they could actually experiment on. To get truly conclusive data, they needed many more trials, but the opportunities simply weren't there. You can't just create a hurricane for an experiment, and you couldn't experiment on a hurricane that posed an immediate threat to land. So the project just ran out of storms to test on. So what did we learn from Project Stormfury? Even though it didn't achieve its primary goal of hurricane modification, it wasn't a failure. Far from it. The project actually led to huge advances in hurricane science. First, the effort to fly into hurricanes and measure their internal structure meant that we got much better at observing these storms. Scientists developed new instruments. They learned how to fly planes safely into the eye wall and other parts of the storm. This data was incredibly valuable. It helped us understand how hurricanes are built, how they get their energy, and how they change over time. Second, the intense focus on hurricane dynamics, on how their different parts interact, led to much better computer models. These models became the foundation for today's advanced hurricane forecasting. While we didn't learn how to stop hurricanes, we learned a lot more about how to predict their paths and intensity. And prediction, knowing where a hurricane is going and how strong it will be, is incredibly important for saving lives and preparing communities. The project also taught us about the limits of human intervention. It showed us that some natural phenomena are just too vast and too powerful for us to control, at least with our current technology. It highlighted the importance of humility when dealing with nature. Instead of trying to bend nature to our will, sometimes the better approach is to understand it better and learn to live with it by preparing effectively. Project Stormfury was a bold experiment. It was born out of a genuine desire to protect people from the destructive power of hurricanes. It wasn't about nuking anything. It was a serious scientific attempt to understand and gently influence a massive weather system. While it didn't end with us being able to turn off hurricanes, it did leave us with a much deeper appreciation for their complexity and a much better ability to track and predict them. And in the face of such immense natural power, better prediction and preparedness are still our best tools for staying safe. The desire to control nature, to protect ourselves, still exists. But now, it's tempered with a greater understanding of what is truly possible and what is not.